Is a prompt optimizer going to do a better job than a human that really understands the problem? Probably not. It's just really, really unlikely. Just like an LLM is not going to do better than an average human at most, as a skilled human at most problems. On the other hand, is an LLM going to do a better job, or some algorithm going to do a better job of giving you a better prompt at a piece of code that you're never going to look at or care about? 100% yes.
Here, I also gave it the output format. Uh, just for fun, let's try not doing that. So how could the LLM possibly know what to return? And
Do you need the sentence in there?
we probably would, but maybe we're just cranking out Bimble functions all day and we're a little tired and we forgot.
So let's start with it having one of them.
Okay, one or the other.
Okay.
Let's give it a sentence.
Yeah, let's just give it a sentence.
It will default weight everything equal, and accuracy comes from the failed versus passed assertion.
Yes.
But you can add additional checks that won't show up as failures, but they show up. You can use them to power ancillary metrics.
Yeah.
All right, welcome back. AI That Works, thank you. Thank you for showing up as always. We've got a episode that I'm super excited about today that has, I think, come up many, many, many times. But before we get to that, let's do brief intros. Dexter, take it away.
What's up, y'all? I'm Dex. I am the co-founder and CEO of Human Layer, where we help people get coding agents to solve hard problems in complex code bases.
And I'm Vaibhav. I work on BAML, where we make a new programming language for building AI pipelines. And today's topic is prompt optimization. Prompt optimization is, I think, a topic that has come up a lot on Twitter. I see it almost everywhere. And one of the most interesting things to really think about is what happens in a world where models can write really good prompts. Are we there yet? Does it actually work? And what is this JEPA thing? Like, what under the hood? How does it work? What is it? Is it just magic sauce? Can anyone write their own JEPA? Is there going to be new optimizers on top of JEPA, or is JEPA a general class of optimization? That's really the questions that we want to dive into today. So that, and
And
then, most important, go ahead.
no, I was gonna say it's a super interesting topic that I'm really excited about because I think we've spent a lot of time on prompting and the nuances of prompting and two dots versus three dots, and we did the whole RTFP, read the actual prompt kind of thing. And so it's really interesting to I'm excited to get your take because I know this is kind of fresh in the world of BAML and the world of prompting. And I know DSPy has been around for a while, but JEPA is this new standalone library that does basically the same approach, but a little more flexible. So I'm excited to. I know you and Greg dug in a lot, and I'm excited to see what you learned and what your take is.
Yeah. So, spoiler alert, we did build a prompt optimizer while we were here last week, and I think it's live and shipped already. So while we're out there, we should be able to see hopefully live prompt optimization on the flow. But I'll tell you my personal opinion, and my opinion has always been this: is a prompt optimizer going to do a better job than a human that really understands the problem? Probably not. It's just really, really unlikely. Just like an LLM is not going to do better than an average human at most, as a skilled human at most problems. On the other hand, is an LLM going to do a better job, or some algorithm going to do a better job of giving you a better prompt at a piece of code that you're never going to look at or care about? 100% yes. There's just no doubt in my mind on that end. And there's a spectrum because software quality is basically based on the amount of time and love you give it. And if you have no love to give to a certain piece of software, it just can't get better, even if you wanted to, right? So an optimizer is great for that scenario. What's your take, Dex? Have you used any prompt optimizers to this date?
I've messed with DSPy a while back. I have not played with JEPA yet. I sit next to a guy in a co-working space who is was way into RL a year ago and has just been ahead of the curve on all of this and was building platforms for hey, let me take your agents long horizon trace and then do a JEPA-ish thing that he was basically an algorithm that he had come up with that was okay, how do we optimize your tool definitions and your prompt and all these different things to improve the trajectory of your agent? So I've been thinking and talking about these things a lot, but I haven't actually gotten to mess with JEPA. But he was telling me actually, like, I think we talked about this episode like 2 weeks ago. I was like, oh, Josh says there's this new toolkit which is like JEPA Pi, which is like a it's like I guess lower level or more flexible or whatever it is. But I mean, one thing that I've been playing with is a lot that it's related is like because optimizers don't work unless you can give them automated feedback, and like we talk about this in coding agents a lot is right. The model can't go and like solve its way out of a puzzle if it has no deterministic like back pressure or feedback system to
Yep.
tell it if what it's doing is working, which is why like unit tests, integration tests, all this kind of stuff is really useful. So I'm a level before optimization because we're still figuring out like our flavor of evals for especially like building workflows with coding agents and breaking up coding agent workflows into like smaller pieces, which actually might be its own a good episode topic to do soon. But
I think the way I'll describe how I think about these coding optimizer problems, and let me know if this makes sense to a lot of people, and then we'll hopefully get into the actual JEPA part pretty soon. We actually have a special guest who's joining us today. We should hopefully be in pretty soon. So the way I've thought about coding agents, it's actually very similar to how coding, like Claude Code, for example, when it edits Jupyter files, Claude Code doesn't actually edit the Jupyter files raw. Because if you ever looked at a raw Jupyter file, it's just a giant JSON blob. So Claude Code
there's
is
a
a
lot
special
of
tool.
noise in there.
Exactly. Claude Code has a special tool in it called edit Jupyter file or read Jupyter file, where you give it an
It's actually
instruction and actually,
notebook edit is the name
oh,
of the
notebook
tool
edit,
I
notebook
love.
read, or whatever it has. And sorry, I don't know the tools as well as you do. And the reason that they had to make that tool was because they want a constrained way of editing this file that is more specific than per se, like than just editing a raw Python file, which is just basically a sed command. Now, with prompt optimizers, you're doing something very, very, very similar. What are you doing? You have a file that describes your prompt's behavior. And what you want to do is you want to apply some edit um, on top of that file, but in a constrained way that only edits a certain part of that file. And that's why I think you really just want a special tool for this. So having like, why do you not want to use general edit tools? It's because of that reason. So like, let's say you have a file that as at least for me, I don't typically write like one data structure per file. I usually have tons of data structures and sometimes related, sometimes not related, more related to a concept that that file exposes than just that one function. But when I run a prompt optimizer, I almost want the prompt optimizer to only pull out the most relevant parts of that system, read all of it, understand all of it, and then edit accordingly. And that's where I think comes into play.
And this is kind of a thing we've talked about a lot, which is like, can you break down your problem into individually testable, individually evaluable, like parts of a pipeline, and then also you want to test the thing end to end. But you kind of those are like almost like two different ways of thinking about the problem, right?
Exactly, because I want to, well, kind of. I think I that's one part of it as well. The thing I was specifically talking about is just like the pure syntax. Like if I have a function, a prompt that has like a system prompt and a message, a user prompt, and I have like a data model that I'm returning in it, that data model may have more nested data models with inside of itself. I might have a class within a class. Like in a
Do you want to
receipt case, yeah,
whiteboard
let's do it.
these
Sorry,
ideas
that's
a
probably
little
better.
bit?
We have got the guest online. Nice. This is Greg. I'll let him do a brief intro about himself, and then we'll get to prompt optimization with him really quickly.
Cool. Hey, I'm Greg. I've been working with Vaibhav and Aaron at Boundary for a little over a year. I work on the compiler, various features in language, and most recently I've been helping out with this JEPA implementation.
What
Thank
Greg
you, Greg.
is not
Uh,
saying is that he's actually smarter than both of us probably put together.
yeah, but that's okay. People can think differently about us, and I accept that for now. Um, so there's like different ways that I was talking about this. So you might have like class item, class receipt, and then like in the same file you might have like a class resume of some kind. When you give the model a prompt optimizer, it's actually a really important question to ask yourself, like, what is the model, what is the optimization system actually going to see? Is it going to see everything? Or are we going to perhaps hide some parts of it and only send it the purple parts, for example, and like void out the rest? And there's two different approaches here. One, I think my naive solution before I actually chatted with Greg about this, and I remember having this conversation, is, oh, well, you just only give it the parts that you wrote, obviously. And then Greg brought up a really interesting point, which is like, yes, but in a shared code base where you're slowly discovering things, you might actually want to use shared types across your code base so it doesn't have to re-optimize that part of the system over and over and over again. I think the exact, yeah.
because the types are part in BAML especially, but in any structured output system, the type is part of the prompt because it's the instructions that you're asking it to do the output in.
Yeah, or not just that. I think, Greg, the specific thing you were mentioning was like you might have like a common system instruction that you're using in a bunch of other places in your code base. And perhaps you've optimized this previously in the past. And let's make the opacity 0. And however, this prompt yet isn't using this. This receipt prompt isn't using this. But you might still want to let the optimizer know, by the way, we do have this common string that we know is used in a lot of other places. And why might you do that? So it doesn't have to rediscover that. The discovery process is just saying, oh, I have this available. It's a tool that I could access. How do you give the optimizer that kind of information? And I think that is a very hard thing to do in an arbitrarily big code base. Because everything, at least, am I summarizing this correctly, Greg, from the way you described it?
Yeah, you are. There's that aspect of it. Like you need to be able to optimize over everything that's an input to your prompt, but also you might be optimizing not just for a single prompt. You have to simultaneously optimize for all the prompts that you're going to use in your pipeline, because otherwise you run the risk of like over specializing that system instruction for one particular prompt, and then it would do less well on the other prompts where it's used.
Cool. So let's go into how does JEPA work? Firstly, does JEPA come with an optimized prompt that it says you should use this or you must use this?
Yeah, the DSPy, when you start using that, comes with an implementation of JEPA that's partly in Python, or the whole thing's in Python. But yeah, part of it is prompting. So there's a prompt. There's actually 3 important prompts. One is called generate candidate or something like that, and that's taking a single prompt and saying like, how could we improve this prompt given its performance on the test suite, and also given the other factors we want to optimize for. There's a second prompt called combine prompts, which takes those two prompts from the Pareto frontier and then has them make babies and see, like how would you combine them to get the best of both worlds to make a new candidate.
So that, and just to clarify there, that means like take one prompt that's really good on being like token efficient and one prompt that's really good on accuracy and try and bridge the two together. Does combined prompts give metadata about why the prompt was chosen from the Pareto frontier?
That one, it gives like rationale on how the combination was done, but the choosing is not generally done by an LLM.
Okay.
Okay, and the Pareto frontier is basically computed based on the metrics that you decided, like latency, accuracy, test performance, token costs, all these different things. Are those metrics prescribed, or do I, as a engineer, have to kind of like pick and choose a set, or do I have to build those from scratch? Like I know I've worked with metrics in DSPy before, but like what do you get out of the box versus what do you have to really like engineer?
Yeah, it's a good question. What you get out of the box is just a single metric, which is what fraction of your tests pass. And then if you want to optimize for other things, there are ways to ask for that. In our system, it's command line flags.
Cool. And then you said there's 3 prompts. Or is there just 2? What's the third one?
The third one is like reflect on like how the prompt performed and sort of get like a score and like how did it perform?
So it sounds like, for me, what the steps of JEPA are, if I were to like pseudocode it, step 1, have some initial prompt that performs poorly and define a bunch of test cases for it. Mm-hmm. Step 2, run those systems, build a metric for that prompt. Step 3, run generate candidates to discover n more prompts that I might want to run. Step 4, run each of those n prompts with the same original metrics I had, or perhaps some sampling thereof. And then step 5, recompute those metrics, define the Pareto frontier, which could be my original metric or the new metrics that I've computed. Step 4, run combined prompts to try and explore more prompts on top of that based on some definition of what came out next. Step 5, run reflect on performance, and I guess that gives me a direction of like which one I should select or something on that direction. Step 5, generate candidates, and do that again forever.
Yeah.
Is that about right?
That's about right. Yep. Basically, you've always got some set of candidates on your Pareto frontier. In the beginning, that's just your single original prompt. And then you generate a new candidate. There's always like one candidate generated at a time. It seems natural to generate a whole bunch, but the way it works is usually just one.
Okay.
And you reflect on that when you run it through all the tests, and then you generate new candidates. And the way you do that can be either just like a greedy hill climbing on the one that you've already worked on, or it can be the combination of two. If you have two or more in your Pareto frontier, you can combine those. And there's various ways of deciding like at each step which one are you going to do. That's all down in like the micro optimization details. Different.
So what I'm hearing is combined prompts is optional only if you actually have multiple prompts that are optimal.
Yeah.
Otherwise, you typically don't run it.
Yeah.
Got it. And then generate candidates otherwise typically go straight to reflect.
So is combining prompts is part of generate candidate, right? Like I feel like this diagram is not quite there. Like reflect on performance probably happens before generate candidates.
Yes.
And generate candidate could either be a net new prompt or combining existing prompts.
That's right. There's a really good diagram of it in the JEPA paper. If one of you wants to Google like JEPA archive.
JEPA archive.
Probably makes more sense than trying to reproduce the diagram of a bunch of PhDs.
So yeah, it's a bit hairy, and some of these blocks we can ignore. They're just like optimization things.
Which blocks?
The D train, I don't think really, that's not like the essential. Thank you.
Okay.
Yeah, so initialize.
Then you determine if you have budget,
Mm-hmm.
and if you do, you run evals
Mm-hmm.
on everything. Yep. And then you ask yourself, well, first you have a candidate pool.
Sorry, yeah, it's going the other.
Yes. And then you just pick one prompt out of your candidate pool.
Mm-hmm.
And then you go ahead and just determine which prompts are actually the best based on some metrics that you have.
Yep.
And then you run either your reflect, you run your reflect prompt or your system order prompt.
Yes.
Got it. Okay. Well, I guess this is all good in theory. Let's run in practice. I know you said you kind of have something. Can we just look at it and just, I know a lot of people in there are asking like, how complex are these prompts? How hard does this actually do?
Mm-hmm.
You would just want to take over screen share and just show how it runs?
Yeah, sure.
I think it's going to be a lot easier. Because at least for me, when I first saw JEPA, I think the way I was looking at it is like, it's a library that I kind of wanted to use, but it also felt kind of overwhelming at the same time because I didn't want to learn all of it from scratch. And then the other part was like, I don't actually know how well this is going to work, so I don't want to invest time into learning it because it just takes time to learn anything.
Well, and you got to figure out like where's the overlap with my intuition that I already know how to do,
Exactly.
and and what are the actual like net new things that I'm gonna have to learn and build intuition for, and like basically put in my 10,000 hours on to be able to get value out of this thing.
Yeah, so we started like diagramming and talking about the implementation. It all sounds kind of complicated, but I think what you'll see is like running it is actually pretty easy, and you don't have to dive into the weeds to have it do what it says on the tin that it does. So on the right, we've got a BEML function, extract subject. Its job is to analyze a sentence and extract as a person the subject of that sentence and their age. And we have an easy test here. The sentence is Ellie, who is 4, ran to Kalina's house to play. The subject's name would be Ellie, the age would be 4. And then we have a more difficult test. Meg gave Pam a dog for her 30th birthday. She was 21. So that kind of puts the LLM through its paces in terms of tracking references.
So what is the answer there? I guess you have one. The answer is...
no cheating. You got to do it without reading the test.
Oh, sorry. Yes, I'm not good at English. But it sounds like the subject is Meg, and then the age is 21 because someone else is 30. That makes sense.
You got it.
I am at least as good as a bad LLM.
Yeah. You are better than Haiku.
Oh, I will take that as a...
And it's unlikely that the dog was 21. That would be a weird gift.
But I can see why LLMs would be bad at this task.
Yeah.
It's quite hard for an LLM to, I think, be good at this kind of thing.
So I did not give the LLM a lot of help with my BEML function. I just had extract the subject, and here I also gave it the output format. just for fun, let's try not doing that. So how could the LLM possibly know what to return? And
Do you need the sentence in there?
we probably would, but maybe we're just cranking out BEML functions all day and we're a little tired and we forgot.
So let's start with it having one of them.
Okay, one or the other.
Okay.
Let's give it a sentence.
Yeah, let's just give it a sentence.
And
Oh.
we're not even being careful to delimit the sentence from the prompt or anything.
I mean, okay, get rid of the sentence too. I guess screw it.
Yeah, let's see.
Let's just see what the model does. I think this is the cool thing about prompt optimizers. Like in this case, we have something that's totally invalid. We have not put the input into the prompt. We don't even have the output type in the prompt. The model knows nothing. So let's just see what happens.
All right, so here we go.
Can you clear your screen and run the prompt at the top? And then do me a favor. Can you zoom in too?
Yeah, zoom it in a little bit.
Zoom in a lot. Zoom in a lot of bits. There you go. There you go.
Oh man, the Bamagen.
Oh yeah, I forgot it.
Okay, and then I'm gonna do one more thing.
Oh, thank you. Okay, so you don't have to run this, and this is just how we get our tokens into the environment. So you're calling an LLM, so when you optimize, you're going to have to pass some credentials, like an Anthropic API key. We're going to run BAML CLI, optimize. You have to pass this flag called beta, because this is a beta feature, not ready for production yet. And then just to speed things up, we're going to limit the number of trials to 3. Let's see what happens. This little viewer comes up, and it's going to start analyzing the initial prompt.
I didn't even realize we have a TUI. TUIs are nice.
TUIs are fun, yeah.
This is a TUI. I do want people to stop calling TUIs CLIs. Like somebody launched this thing, it's like, this is the new XYZ CLI. And I'm like, this is not a CLI, this is a TUI. A CLI is like inputs and outputs on the command line.
Yeah.
So what's interesting here is like you're showing me the prompt down below.
Yes, so this is the original prompt.
Yeah.
And we're getting our metrics. The only metric that we're starting with is the accuracy, how many tests passed out of how many we wrote, and that's 0. Now we can scroll down to see the first candidate that optimization wrote, and we see what it did was it put in a system role, and then gave way more detailed instructions. It's
that's like, better instruction than I would write for sure.
Extract the grammatical subject. That's a really good disambiguation. In this TUI, I have to apologize, my scroll bars don't work. So you'll have to zoom out if you want to see more.
Okay.
And we also see that that the optimizer knew to put in context.output format. So we did not just copy paste the stock JEPA prompts from DSPy. They wouldn't work for BAML. Those prompts need to know like how a BAML prompt works. So they need to know about Jinja and output format and that kind of thing. So now they know, so you don't have to. And then what else happened is we ran the tests, and we see that on this first candidate, we already got up to 100% accuracy. So that is convergence. The algorithm stops as soon as you max out your
metric.
Your metric. If you
sure, because there's no better way to go. It's like if your metric is 100%, where else are you going to go?
Mm-hmm. Mm-hmm. Yeah. As I'm saying that, I realize I might be lying. If you set trials to 3, it might be like
it might force it to run
all the way out. Okay. And then once you have these metrics, you just you pick one and you hit return on the one you want, and it's going to overwrite your original BAML prompt
on the way.
On the way. And I don't want to do that because I want to keep my old crummy prompts for other demonstrations. I'm just going to hit Q instead.
Okay. So now we have this. Can you go back to the run information, the file directory?
Oh, so, yeah.
And zoom in for me on the screen as well.
Can I zoom? I don't think I can zoom here, but I can't zoom on the browser, the file browser.
Oh, that's very weird. So the other thing you get is a run history. So you can actually go into here and just see like any of your run histories down there and just see what's going on. So you can actually see like the past prompts. Now,
this is the new BAML file. Is this done by actually you're manipulating the AST itself to generate the new code, right? So you can just like splice in the new prompt where at the part of the AST that matters.
That's right.
That is right. So,
cool. The candidate generation gets the full BAML source, or does it get the AST representation?
Gets a subset of the AST representation. It gets like everything that's reachable from your original prompt.
Yeah. So we talked about this earlier in the very beginning. It's like, what if your code base is big and every code base where you need to optimize your prompt is a big code base. Like otherwise you don't need to optimize your prompt because you're probably not doing something very serious. So in that world, how do you give the optimizer the minimum set of code it needs to actually think about? So we actually go through the AST, say you want to optimize this function, so we pull out everything that you might actually need and put that into there for you. Now, there's a really interesting thing in here, which is like, but what is the JEPA prompt? I know you told me it does BAML stuff, but what is the JEPA prompt? And what if I want to change it?
Good question, Bob. Yeah, so that is that's actually.
Oh yeah, it's okay. These are the prompts that it uses to generate the candidates and reflect and things like this, right?
Yes. Yes. Like exactly. What does that generate prompt? What is a combined prompt? What is the reflect prompt? Where do they live? How do I edit them? How do I control them? How do I use the model that perhaps I have a proprietary model that I fine tune for this?
Mm-hmm.
Oh, sick! And of course, this is implemented in BAML as well. Nice.
Yeah, as everything should be. Yeah. So it's a fairly heavy BAML file. We had to basically teach the LLM reliably how to write BAML code in a prompt in this file. It's called jepa.baml. When you first run optimization, you're going to get this .baml_optimized directory like in your project, and most of the files in there are run history. But there's also this directory called jepa inside, which contains the jepa prompts. You can customize those before you finish running optimization. So like you can run optimization basically in dry run mode, and you'll get this jepa.baml file.
I was going to turn it to light mode.
Oh.
I don't know how to do that though on your computer.
Yeah, the Zed, I love Zed, and it's so fast, but I have found that the command prompt palette does not, like, I had to go Google what do they call soft wrapping in this one in Zed. It's got a different name than in VS Code.
There you go.
I don't know if that's easy for people to read or not, but it might be. Yeah. Okay. So in this Java prompt, show me the 3 prompts that you talked about at the very beginning.
There you go. Reflection functions. Propose improvements.
Okay. And that takes in a function, takes in failed examples, and then, that's interesting. Can you close word wrap so we can see all of it? It's actually right.
Okay. Let me manually do that.
All right, so I'm actually really curious about what all the things that we send into it are.
Okay.
So you always give it success.
Yeah, and I want to see that. Can we see the types of these too? Would be really interesting.
Yeah, optimizable function. Oops.
Oh, you didn't install the BAML VS Code.
You guys need an LSP for Zed, Vaibhav.
I think we do have one. I think Greg just hasn't downloaded it.
Yeah. An IDE letter. Yeah, so optimizable function tracks a function name, prompt text, reachable classes, reachable enums, and the source code
of the function.
Okay.
So you actually give it both the prompt text and the function source. And why do you do that? Is that because of like pulling in code from template strings and seeing the full prompt rendered out?
I forget exactly what, but I think it's that we needed to know not just the prompt and not just the function name, but also like the names of the arguments and the types.
Yeah, makes sense. You need the names of the arguments and the types, and like we could optimize this and make it even better, but this would definitely make it possible. Makes sense.
And when you say reachable classes, is that basically every class in the namespace that is accessible? Basically, like if I have 50 BAML files, it's going to include every single class that's available in my BAML source directory?
No. Just the classes that you mention in the inputs and the classes that you mention in the outputs, and any classes.
And then traversing that tree that those things all reference recursively?
Yeah, right.
Okay, cool.
Yeah.
Okay, so if there's other classes, if I didn't put person in the signature, then the optimizer wouldn't know that I had a person class.
Yeah, correct. Now, I could imagine a scenario where you want to explicitly tell the model, I also have these other data types, and we include those as well. But I would say that's like an extra thing that you do, but the default thing should be to give it the minimum set of code that you want to optimize on. So let's go on. So let's just read the prompt. I'm actually really curious how this prompt pans out because I think it's one of the most fascinating things. It makes sense that the proposed improvements knows the failed and successful. What's optimization objective?
That is the list of all the metrics that you care about and their weights. So that would be something like accuracy 50%, input tokens 25%, completion tokens 25%.
Got it. And you're just telling the model, I care about this in this way. Mm-hmm. And it can't really, I guess it can't really actually understand the weights. You're just giving it some relative subjectiveness. So giving an accuracy of like 0.51 versus 0.5 doesn't actually make a difference since it's going into a model input. Mm-hmm. But you're really trying to give it relative importance. It's like, this is twice as important as this other thing. So you don't need to be specific, just like orders of magnitude is what you're trying to convey.
Exactly. Yeah.
Got it.
Cool.
Current metrics, that's like the result of the current prompt.
Yeah. How well did that?
Against your optimization objectives.
Exactly.
Okay, now I have another question. Cool. Mm-hmm. Did you JEPA the JEPA prompts?
Good question. No, I did not JEPA the JEPA prompts.
Okay.
But I'm sure if we did, this would work even better.
Okay.
Yeah. How would you compute metrics of the you kind of have to know a dumb prompt and then know the best final prompt and then optimize against its ability to reach that, right?
Yeah. So the inputs would be prompts and outputs would be performance of the optimization process over those prompts.
Yeah.
And I can tell you when you can maybe get a hint of why that becomes kind of a pain to do here on line 104. Usually in BAML, your prompt starts with a single hash and then the quote to make a raw string. Double hash is if you need to use single hash quote inside your prompt for some crazy reason, then you can use double hash to get an extra
escape
level of rawness.
Yeah.
The more recursive.
How many hashes are supported?
Nice.
Can you have 50 hashes?
7
hashes.
7 is the max.
So you can have 7 different layers of hashtags within hashtags in your system.
Yeah.
Okay.
If you want to optimize your optimized prompts.
Well, I want to go down and see a couple more things. What are the most interesting things that you discovered when you're actually writing this?
I think I ended up iteratively adding a lot of stuff that I didn't realize at the moment I would need, but in hindsight is extremely obvious. So one example is what you asked about before, the full text of the function. This is an interesting factoid for prompt prompt engineering in general. It's so hard to remember your own implicit knowledge when you're prompting, and to remember the fact that you have to be explicit about all those things. And implementing this was a huge reminder of that, because when I look at a prompt and I see it fail, it's fairly obvious for me to think about how to improve it. But it's not obvious for me to enumerate all the things that I know when I'm doing that. So seeing optimization fail over and over and realizing, oh wait, that's because of course this prompt has no idea what the failure cases were. It knows the test fails, but it doesn't know the source code of the test that failed. So it doesn't know what it's trying to get the prompt to actually do.
Because it's not actually sufficient to say the test failed. You really want to say the test failed because this specific field is missing, and you want to be as rich as possible on that. And not only do you want to do that, if you only show the failure message, let's say you have 5 asserts in your test case, whatever test case you write, and the second one failed. Well, if you gave the failure message a second assert, the model can't look ahead and say, I also need to look at all these other failure scenarios as well and optimize for all that as well. Otherwise, what might happen is you pass the second one, now the fourth one failed, and you're just wasting iteration time. And because the model can reason about source code, putting the whole source code in there is way more optimal than just the failure string itself. That's really interesting. I didn't think about that. I would have, the naive person in me would have just put the error message of the assert statement. Mm-hmm. And I can see why that's just strictly worse in a lot of scenarios.
Yeah.
Let's go on. I want to see more of these prompts. So we have the new improved function. This seems to work. I assume you do a lot of stuff in here that you can render different stuff in here.
Yeah, we're rendering the current metrics. We're rendering the optimization objectives. And then we include some instructions about writing BAML.
Got it.
Merge variants. We've got 2 optimizable functions, which some of you referenced.
Okay. So merge variants is the combined prompt that you have. Oh, and that's where strengths come from.
Strengths come
Where do those
okay.
what generates those strengths? And
Reflection.
Reflect.
we could focus on this one first, but I also want to see how we're generating the strengths. Okay, that makes sense.
Yeah,
The reflection step is what tells it, okay, here's what these ones are good at. Okay.
Okay. So this
And reflection model is just an LLM that supports thinking or something, right?
we'll point to that in a second.
Oh yeah, that's like a great.
Oh, it's just these are just names for like which LLMs are doing which parts of the work, basically.
Yeah.
Do you want to? I can show
Yeah.
that really.
Yeah,
quick.
just do it.
In our case, reflection model, like all of the prompts are called like the reflection prompts, and they all share the same model. But you could change that if you want, because you can customize JEPA.baml. And yeah, right now we've got that set to Cloud Opus 4.5, and as models get better, you could choose different models here. Or if you discover that for some reason the combined models function is taking too long, and you think it's a fairly simple task, you could specify different LLM providers, and you could use those in your different prompts in JEPA.baml. So you kind of pick and choose how much power versus price you want for the different stages.
Yeah. And I get, yes, that's interesting. You can choose not just the model you want, but actually swap to different models for different stages. That's very fascinating. I didn't think about doing that. Does JEPA do that by default?
I don't know.
Okay, got it.
You mean our implementation?
Yes.
No, we just use one model for everything.
Okay, what does JEPA do by default? No stance made?
You mean, well, there's different
The
implementations.
the DSPy implementation or the default JEPA library implementation?
I know there's a command line argument that you can choose which provider to use.
Okay.
But I don't know how much control you have over like which specific model.
Got it. Yeah. Cool. Let's go on. Let's go back to the second prompt. So this prompt looks pretty straightforward. Merge two variants. Makes sense. And then it kind of just looks at both functions as this is the better ones. Yeah. Got it.
So this is
you don't give any ideas about the scoring or anything or the final objective in this prompt. You purely just say these are two good systems, make them better by combining them in some way.
Let me remind myself what's an optimizable function. I think you're right. Yeah, okay. We don't reiterate. And that might actually make this prompt perform better if we remind it relatively.
Cool. And then let's look at the next thing. Right there.
Analyze failure patterns. That's what I've been kind of loosely calling reflection. But,
okay.
The whole algorithm kind of thinks of these three together as reflection. So sorry, being a little inaccurate. But yeah, this is the one that's more like introspecting on like how did the model do and why. So
and it specifically looks at failures.
Yes.
So I'm guessing if you have no failures, you don't call this.
You might call it with an empty list.
Okay.
Or maybe you don't call it at all.
Okay.
Yeah, I think it gets called with an empty list.
And what's the output type of this?
Let's see. Failure analysis, which doesn't tell us a ton. Let's go look at that class.
Okay.
Okay, so like in what ways did the thing fail? Common patterns, to be totally honest, I could not remember what that does at the moment. And recommended focus, like looking at all the failure cases, what would be the most fruitful thing to optimize if we were going to make a new version? And naturally that comes from like, was it mostly failures in tests that happened, or was it mostly that like there were too many output tokens or too many components?
Got it.
Question. So I understand there's probably been tweaks made to the how do I say it? Sorry, I just I saw what you had selected in the search bar, and it made my brain skip a beat.
Mm-hmm.
There's some tweaks to this that you have done to make it more BAML specific, but as far as the types and the outputs and things like this, to what extent does this follow kind of the core JEPA paper? Like, was common patterns one of their things? Are they just outputting all this in Markdown instead of structured output? Like, what percent has this kind of departed from what's prescribed in the paper versus like what you wanted to do to make it more BAML, more BAML fluent and understand BAML code, but also more, hey, I want to use the structured output things that BAML is really, really good at to build, a best-in-class JEPA implementation.
Yeah, it's like 50% faithful, 50% departure. And you mentioned some of the for departure, like we have BAML-specific stuff we need to do. But also, like DSPy has been focused on this exact problem for a couple of years or something. So they have like a ton of different ways of customizing their JEPA implementation. Yeah, I mean, you don't have to use JEPA. There's like many different optimizers you can use in DSPy. We didn't want that to be like our core focus. We just wanted to basically take the best algorithm and give something that's kind of like convention over configuration for the most part, and just let you get some level of optimization. There's some tunability, but we're not trying to go like all the way and completely faithfully implement that algorithm that they are sort of kind of carrying the standard for and constantly improving and pushing the state of the art on. And also because they're pushing the state of the art and they're like purely focused on this, they kind of have a different set of constraints. Like we absolutely want to stay focused on like the core BAML story where you always have like the types in hand and the prompts in hand, and you sort of want to be, although you don't have to like nitpick the writing of the prompts, it is still part of our thesis that you should always see the prompts, and you should see the prompts before and after it gets rendered. And that comes through in our UI, and it's like a philosophical difference from DSPy, which sort of is exploring another sort of developer experience that says you shouldn't have to look at your prompts. That's kind of an implementation detail. And these are just like two philosophies that push you in different directions. And that's a reason for more of the departure between the two.
Yeah. And I would say,
you define your output types and your input types and some very high level around like what does good look like, and you don't think about prompting.
Yeah. And furthermore, not only you don't, it's very, very hard to actually get the prompt out if you wanted to. And I think the difference really is like, I suspect most of these categories and stuff, these structs that we've defined, philosophically probably follow the exact same steps because we followed the JEPA paper pretty closely. But the exact prompt itself, like I don't think JEPA says this, thou shalt write this prompt. I think JEPA is more of a process and the mechanism of doing it. And I suspect that the data models and stuff enable things like, for example, building that TUI that we showed earlier that make it very different. If you don't have those data structures, you can't build a TUI. You just have to look at like raw strings, right? Because you need structs to highlight things red or green. You need like arrow keys to navigate to the right system. That just requires structure in some form factor or another.
Right. At the end of the day, under the hood, if you're okay with hiding and black boxing everything, you can just have LLMs passing markdown back and forth to each other all day. But if you want to actually be able to structure the output and give someone visibility into how the optimization process is going and what's the steps and the rationale, all these different things, then you're going to have to structure it at some point. So why not make the plumbing be structured rather than just, okay, there's markdown flowing everywhere, and at certain points we will generate structured objects from those pieces. Is like the only other way I could think to do that. But again, it's like this makes a ton of sense.
Yeah. And then the other side effect that you get here is like, because all these prompts are now exposed, they're no longer like an implementation detail. You as a developer might find that, hey, just like we found it beneficial to tell the LLM a little bit about BAML and like Jinja and small things like that, like how do you escape strings and tricky things that like you might not want to include. You as a developer might be working in a very specific domain, and you might actually want to tell it about specific types that you have in your code base. You might want to tell it about like very domain specific information that only the optimizer needs to know about. You might want to tell it certain things about your eval set, like, hey, like don't over index on this specific test, because like this test is just known to be extremely hard and we don't really want to care about it. And typically the way to go do that, I think, would be very hard. But one of the most important things that we were thinking about when we were thinking about prompt optimization was like, how could I as a developer not only have control over my prompt and my types, but also have control over the optimizer? Because the optimizer itself is a prompt and types. And I think that is like the more interesting system here. And then soon, I think someone else asked about this, is you probably don't want to optimize just like LLM functions. You probably want to optimize entire workflows. And that might include optimizing LLM functions. That might include optimizing control flow around LLM code. It might kind of be a combination of both. And you want the model to be able to do all of that. And I think that hopefully is a thing that we can enable soon as well, which is beyond just like, hey, make the prompt better. It's make the whole system better. What's your...
Some very cool links in the chat here.
I know.
Yes, a meta optimizer for optimizing LLM optimizers. Someone already did Jepiception.
Yeah, I figured. It's like the most intuitive thing to do on top of that. But a question I have for you is, I guess the nice thing here is one question I did not see answered that I think someone else asked a little bit ago is, how do I write my evals? Greg, how do I write my evals?
Yeah, we didn't want to change the language to let you write evals, and we wanted everything to be like in BAML as opposed to in DSPy, everything's in Python. So you basically we kind of shoehorned evals into our existing test infrastructure. Already in BAML, you can write test cases like this. So you choose a function that's on the tests, you give it its arguments, and then you can write some assertions over the running of that BAML function. Those are the evals that we have to work with. In the future, I think we could like extend this pretty easily through the CLI arguments. Like if you wanted to pass like a CSV file full of pairs of inputs and test cases, we could do things like that to sort of like streamline this again without changing the BAML language. But yeah, that answer the question?
Yeah, you just write a bunch of asserts along the way.
Yeah.
And then the next question I have is like, I think we were talking about like, as a part of like the JEPA algorithm, a large part of it is not just finding one metric or two metrics. What metrics are there? Like what metrics can I run? What can I not run? Where am I shoehorned? How do I run a custom metric?
Yeah. Again, because we were trying not to change the language at all, we had to use like existing stuff to put custom metrics in there. And we have this thing already called check, which lets you name an assertion and make the assertion soft. Like checks are not hard failures. So using this, we can sort of discriminate between different types of failures. And you can have multiple checks that are called the same thing. Maybe we'd put this one in a different test. Or I'll put this one in our test about. And now that we've got a check that has a name, we could use that as a weight when we run optimization.
Oh, sick.
Yeah.
So it will default weight everything equal, and accuracy comes from the like failed versus passed assertions.
Yes.
But you can add additional checks that won't show up as failures, but they show up. You can use them to power ancillary metrics.
Yeah, exactly.
That's cool. That is cool.
You know,
That's freaking very clever. Like I love like, hey, what are the boundaries of the language and what does it afford us, and then how can we use it to deliver this thing without adding an entire new language feature?
Yeah.
That's really cool. What about if I wanted to optimize for like input tokens as well?
Oh yeah, that's a hard-coded one. That's called prompts token.
You have a bunch of built-in ones.
Yeah.
Got it. Okay. Got it. So then you can just go to, and I noticed it doesn't have to add up to 1, so I guess I can put it in whatever I want, and the model will just figure it out.
We use advanced
What if you
norm tech.
What if you put in like prompt tokens matters 100 times as much as accuracy?
You will get very short.
Press enter. Let's run it.
What? Age check.
Oh, you
Doesn't
need.
like the age
You might
check.
have to write check colon age check.
Check colon age check?
Yeah, it's check colon age check. It's how we namespace it. There you go. The error message told me that. Sorry,
Oh,
it was
dang.
in my big brain. While this is running, so funny. So what is P? Oh, it actually shows me my prompt tokens.
10,000%.
That's cool. So you actually show me prompt tokens because like now it's relevant to my metric. By default, you don't show it.
Oh, and this is going to be a tough one to optimize because remember our baseline prompts was very spartan.
Okay, so now it's passing, but the prompt tokens went up to 86.
So it's on the Pareto frontier, but not because of the main metric that we care about.
It's not even making.
All right, tried another one.
Not doing it.
I want a shorter.
It looks like the age check isn't passing for some reason. That seems like maybe a blip, a bug. I don't know.
Yeah, it's probably a bug. We haven't released this yet.
Oh, we made it shorter, and it still passes.
Oh, that's pretty good, actually.
Nice. Wow. Oh yeah, and you see how it made it shorter? It used aliases for these.
Oh, that's cool. That is cool.
All right. Hell yeah. I'm glad I asked.
Yeah, that was a good question. I think if we give it more than 3 trials, it would probably cut some of the fat from this prompt as well.
Prompt optimizers are pretty good. I think
That's sick.
I think the key point here is like, I think we shouldn't live in a world where we have to handwrite our prompts. We should live in a world where we can have prompts be automatically generated, because it does help us explore the state space much, much better. But I think living in a world where you don't ever read the prompts is also a problem. Like, for example, the fact that we all just looked at this really quickly. I remember earlier, there was a whole point that someone else made of like, oh, isn't it overfitting? If you don't look at the prompt, you can't possibly know if it overfit by accident or not. The metrics are not enough. Because like we said, one of the benefits of JEPA is you don't need a lot of sample points to end up with a good solution. But then it's very, very easy to accidentally have overfit if your sample points are actually not representative of the actual overall problem. And you got to see.
And you're talking about a thing. Sorry, go ahead.
No, go ahead.
No, you're talking about a thing that I think is super, super important that we talk about a lot. Like we did the evals episode. You're like, dude, just do for the first pass. Like it's like 80-20 rule, right? Like your human intuition is incredibly powerful. And if you can just look at something and know if it's good or not, that's way cheaper than designing 50 metrics or trying to figure it out. And I think a challenge in AI, if you're going to build like AI that works and production systems, is like you can't lead too far into this futuristic, like when the models are amazing, we won't have to think about anything and they'll just like Inception optimize the optimizer for the optimizer. And then it's like, okay, but what's actually possible today? And what is a really valuable use of my human intuition and leverage, which is like, cool, use an optimizer, but also look at the prompts because you can in 5 seconds see if something's been over optimized, overfit or whatever it is.
Exactly. I think like that's the world that we want to live in, is like some blend of those two systems where it's super easy to understand that. Funnily enough, I have another question that I think a lot of people are asking is like, does JEPA thing seem super complicated? And that was my first opinion of it too when it first came out. It's just like, man, it's going to take forever to add it to BAML. That's why we haven't added for a long time. But how long did it actually take, Greg? Like literally from concept to working and I guess to merging soon.
It was 3 days.
3 days of work. Fully, with all this tooling that you're going to see over here. It's not that hard to understand JEPA. It's not that hard to even build it on your own. Most of these systems that you're building are not that complex. Anyone can go build them. You can build it on your own. You don't have to be tied to, you don't even have to use our system. You can use your own system if you want to go build it. That's the whole point. So,
okay, so the new to-do list app that everybody implements
JEPA.
In 2025, it was everyone should build a coding agent from scratch, and in 2026, everyone should build a prompt optimizer from scratch.
That's right. Everybody should build a prompt optimizer from scratch. That's what we should title this episode.
I love it.
We'll take some more questions from people on here if they have anything to share. And I see the first one over here, which is, would BAML keep the original prompt versus a suggested one before a developer accepts the improved prompt? So how do I actually replace the prompt in my code? So right now, if I quit, it won't update my prompt at all. How do I actually replace my prompt?
The CLI gives you an option. You select the one you want. Like here, I'm selecting different ones. If I hit enter, it's going to replace.
Okay.
There's also like you can run the thing in non-TUI mode, and then you'll get like a pop, like a question, where you answer by hitting 1, 2, 3, 4, 5. Like, which prompt do you want to replace your existing one, or none of them? Hit Q.
Got it.
That kind of thing.
Got it. So you just select, and then we just replace the AST with all the updated code accordingly. Okay, let's ask another thing. During optimization, are input and output types treated as hard contracts? Types can't be changed during optimization?
Correct. That was a decision that we had to think about, because of course you can optimize the types themselves, like the fields, what fields there are, what their names are. But because users are generating client code, like TypeScript and Python code through CodeGen from the types, we didn't really want to mess with that. because then like optimization is going to change something about the way that you have to consume those types in your application. And that seemed like too much of a pain for users. So that's why we only let you change the prompts and metadata on the types, like descriptions and aliases, which don't affect the generated client code at all.
But we could pass in an argument that says types can be changed if we wanted to.
We could, yeah.
Cool. That's interesting.
Guys, this was a blast. This is super sick.
Are the docs live?
Yeah, we have docs for all this. Risky. Mario, just check it.
Was that a chat message you complaining to Vibov how much you hate going on his podcast?
AI that works is a mandatory company-wide attendance policy.
Prompt optimization.
Okay, so we have a docs on prompt optimization on there. That I guess does that click on it?
It clicks.
Oh, it clicks. Nice, and it tells you exactly how it runs and describes some of the behavior on here that we showed.
Exactly.
Oh, this is dope.
I'm actually you know, it's funny. I'm probably going to do this for most of the prompts that I get. Because, for example, whenever I go and show people different prompts and help them migrate over, I just run this manual prompt optimizer in my head. But this is just so much better.
That's another reason we didn't implement that at Boundary prompt optimization, because we already have Vibov.
Yeah, Vibov, the human prompt optimizer.
Yeah.
I have one last question. I know we're gonna probably wrap up soon, but I'm curious. I know Vibov built a coding agent in BAML like 4 or 5 weeks ago for one of the episodes. Have you all thought or tried to apply this to longer horizon, multi-turn style systems? Like, would you build a coding agent and then plug this into Swebench and see where you can get with it?
You should be very excited for what we're going to release in January. It hopefully, I think in theory, should work with this optimizer out of the box with almost no extra work, and that will be really
excited.
Fun. And Greg is sad because he feels like maybe I just signed him up for more work, but it's going to be really fun. Specifically in the form of like how to define custom metrics, how to define custom evals. Like check is a great solution, but I think there's a more interesting one that we could build that's even better. And then most importantly, is this open source? Is this public? Can you go see how we actually build it? The answer is, of course. Like we said, this stuff is not hard. It's pretty easy. So there's no point in trying to close source this. Can you show the code really fast, Greg? If any of you are interested and want to go look at these prompts in more detail, want to go read some of this stuff, want to read how the harness around it works, I think that's going to be really interesting. So we probably won't link this code directly in the AI that works repo, but we'll point to it here. SRC, CLI probably. Oh, even better. And like the whole harness and everything is in here. There's some defaults in here that I guess probably have the regular prompt as well. And you can just read all of it. And you can just like go through, understand how we optimize the prompts, understand how we built the harness around it. Because the harness is just as interesting as the actual prompts themselves. And I think it's worth everyone taking a look at it from. But hopefully this is going to be fun and everyone's going to have a lot of fun. And hopefully use cases that come out of this as well. Any other questions?
To see what people build with this.
Now, for everyone else that's still here, remember, this is AI That Works. We host events every Tuesday where Dexter and I talk about various topics in AI. We typically try and do our best of showing real code. And I know today we didn't show real code, but we did show a system that works that you can use that I think will be out today or tomorrow, where you can actually run an optimization function. Hopefully the use case of how we described a JEPA makes sense to everyone. You can try and build your own JEPA if you'd like. And then last 2 weeks episodes I think are going to be really fun. Next week we're actually gonna close out this year with 2 of what I think are going to be my favorite episodes. My favorite episode is going to be next week, which is going to come through Dexter, where we're going to hear Dexter's background story and exactly how he got to building where he's going, how he got into YC, how he got into the whole session of being a founder, what it's like being a founder in this age, how he met his co-founder, and the whole journey behind code layer, context engineering, and everything around that session. So I'm incredibly excited for that conversation.
And then after that, we're going to do the same thing to Vibov, and we're going to hear his story of getting into YC, getting told that his idea was bad, pivoting 12 times, and landing on deciding to do the hardest thing that anyone's ever done in I think like building software, which is like creating a brand new programming language.
Operating systems might be harder, just to be very clear and transparent. But
interesting.
I at least I think so. But I think it'll be a fun conversation, and I think Aaron's going to be joining me as well, so it'll be a lot more fun because
sick.
He's a lot more entertaining than I am.
All right, y'all. Well, thank you so much, Greg, for joining us. Thanks, Vibe, as always. This was a super dope topic, and we will see you all next week.
Sounds good.
Bye-bye.